The solubility of carbonate ions. We have ammonium carbonate salt, a salt of arsenic carbonate, and calcium carbonate. Carbonate are usually insoluble in water except ammonium carbonate. The salt of ammonium carbonate is soluble in water. We will take some salt in test tube and will add distilled water. We will shake the test tube and we will check the solubility. Salt is completely dissolved in water. This shows that ammonium carbonate is soluble in water. Now we will check the solubility of calcium carbonate. We will add some salt of calcium carbonate in a test tube with the help of a spatula. Now we will add distilled water to this, and you can see the turbidity in solution. Solution is not transparent. That means calcium carbonate is insoluble in water. Carbonate ion belongs to group 1 of acidic radical, and it can be tested with group 1 reagent, either dilute H2SO4 or dilute HCl. Just to test the carbonate, the presence of carbonate in salt, we will do preliminary test. We will add some salt to test tube. Now we will add the reagent of group 1, which is dilute H2SO4. As soon as we add this reagent to the salt, brisk effervescence will evolve. This is due to the formation of carbon dioxide gas. This shows that the salt has carbonate ions in it. For confirmatory test of carbonate ions, we will pass carbon dioxide gas to lime water. The formula of lime water is CaOH whole twice. As soon as the carbon dioxide gas comes in contact with lime water turns milky due to the formation of calcium carbonate. We will wait for some time because this process takes 1 or 2 minutes. After few minutes, the lime water turned milky due to the formation of CaCO3 or calcium carbonate. Now, if we'll pass this carbon dioxide gas in excess, the lime water or the milkiness of lime water will disappear, which will be due to the formation of calcium bicarbonates. So, the preliminary test of carbonate ions can be done with the help of dilute H2SO4, and the confirmatory test is done with lime water. You have seen that how lime water was turning milky when we were passing carbon dioxide gas to it. So, this is a test to detect the presence of carbon dioxide gas also. Now, test for acetate ions. Acetate ions or acetate belongs to group 1 of acidic radical, and it can be tested with the reagent of group 1, which is dilute H2SO4. It can also be tested with the help of dilute HCl. We will take some salt in test tube and we will add very slowly dilute H2SO4 to this. As soon as we will add dilute H2SO4 to this, salt will get decomposed and the solution will give a smell of vinegar. Acetic acid is the main constituent of vinegar. So on heating or on adding dilute acids, the smell of vinegar comes from the solution. For confirmatory test of acetate ions, we are taking some salt to a test tube. Now we will prepare aqueous solution of this and we will add some distilled water to this. We have prepared a solution of acetate ions. Due to the presence of acetate ion, this aqueous solution is also acidic in nature. We will test this with the help of a litmus paper. You know, acid turns blue litmus to red as soon as the solution comes in contact with blue litmus paper. The blue litmus paper will change its color. We also know that acetic acid is a weak acid, therefore the red color of litmus paper is not so dark. It is very light. It's light pink color. So the presence of acids can be tested with litmus paper. Acid turns blue litmus to red and basis turns red litmus to blue. The confirmatory test for acetate is done with the help of neutral FeCl3. The salt of FeCl3 is slightly acidic in nature. We just do it neutral with the help of either adding plenty of water or few drops of base to it. And when we add neutral ferric chloride to aqueous solution of salt which has acetate ions in it, when we will add this neutral FeCl3 to the solution will turn reddish brown. You can see the change in the color. A reddish brown precipitate is formed in test tube. This shows the presence of acetate ion in the given salt. This reddish brown coloration is due to the formation of ferric acetate. Acetate ions reacts with ferric ions. We have used FeCl3, that means ferric ions were present. The ferric ions react with acetate ions and this coloration is due to the formation of ferric acetate. Now we will check the presence of chloride ions in the given salt. The common salt which contains chloride ions in it is sodium chloride, which is generally used in our homes. Another important salt of chloride ion is calcium chloride. Today we will test chloride ion in ammonium chloride. First of all, we will perform preliminary test. We will do dry test to check the presence of chloride ion. For this, we will take small amount of salt in a dry test tube with the help of a spatula. Then we will heat this over a Bunsen burner. For this, we will use a test tube holder. On heating, HCl gas will evolve, and how we will check the presence of this HCl gas. We will dip a glass rod in ammonium hydroxide solution and we will put this glass rod over the mouth of test tube. The formation of dense white fumes confirm the presence of chloride ion in the salt. Basically, chloride ions react with ammonium ions present in aqueous solution of ammonia and forms ammonium chloride. The white vapors formed are of ammonium chloride. Now we will do another test of chloride ion with the help of concentrated sulfuric acid, as chloride ion belongs to group 2 of acidic radical, and the second group radicals, acidic radicals, are tested with concentrated sulfuric acid. For this test, we will again take some salt which contains chloride ions in it in a dry test tube with the help of a spatula. Now we will add concentrated sulfuric acid to this with the help of a dropper. Dropwise we will add this concentrated sulfuric acid to the salt. Now we have to heat this test tube. For this, we will hold the test tube with the help of test tube holder, and we will heat this content over the Bunsen burner. On heating, colorless pungent gas evolved, which is actually HCl, and we will confirm the presence of this gas with the help of aqueous solution of ammonia, that is ammonium hydroxide. Again we will dip a glass rod in aqueous solution of ammonia and we will bring this glass rod over the mouth of test tube. The formation of dense fumes confirms the presence of chloride ions. So the dry test as well as the test with concentrated H2SO4 are the preliminary test for chloride ions. Now we have to confirm the presence of chloride ion in the salt. For this we will do confirmatory test. The confirmatory test of chloride ion is performed with the help of one reagent, which is MnO2 or manganese dioxide. Again we will take some salt in test tube. Then we will add solid MnO2 to this. Now again we will add concentrated sulfuric acid to the test tube. We have to heat this content over a Bunsen burner. The formation of greenish yellowish deposition on the walls of test tubes confirms the presence of chloride ion in the salt. Chlorine gas evolved in this process and chlorine gas gives greenish yellowish color. Whenever you are doing heating, you have to be very careful. Another confirmatory test for chloride ion is done through silver nitrate solution. For this we require AgNO3, dilute HNO3 salt, and distill water. The process is same. We will take some salt in a clean dry test tube. We will prepare aqueous solution of it. For this, we will add distill water to the test tube. We will not use tap water for this because tap water also contains chloride ions. So we will prepare the aqueous solution of salt in distilled water. Now we will acidify this solution with the help of dilute HNO3. Now we will add silver nitrate solution to the test tube. The formation of white PPT shows and confirms the presence of chloride ion. Basically, silver ions from silver nitrate solution reacts with chloride ions and gives a white PPT of AgCl. See, this beautiful white PPT is of AgCl. So this is another confirmatory test for chloride ions. Move on to another acidic radical, which is nitrate. Nitrate is NO3 minus. That means it is anionic part of the salt. Now we will see the presence of nitrate ion in magnesium nitrate. We have the salt of magnesium nitrate and we will check the presence of nitrate ion. As nitrate ion also belongs to group 2 of acidic radicals, that means we have to test this anion or acidic radical with the help of concentrated H2SO4. Please do remember the reagents of all the three groups. Group 1 we have done with the help of dilute H2SO4. Now for group 2 we are using or we will use concentrated H2SO4 or concentrated sulfuric acid. For the test, again we will take little amount of salt with the help of a spatula in a clean dry test tube. Now we will add concentrated sulfuric acid to this. Now we will add the content of test tube over the Bunsen burner. Nitrate ion belongs to group 2 and group 2 radicals gives colored gases on heating, as chloride ion gave greenish yellowish color. Here we will get brown fumes and these brown fumes are of nitrogen dioxide. You can see the brown fumes on the wall of test tube. The brown gas or the brown color vapor shows the presence of nitrate ion in the salt. Now we will add copper turning to this. Addition of copper turning will intensify the formation of brownish vapors in the test tube. We will add copper turnings. Copper turnings are basically the ribbons of copper metal, and again we will heat the reaction mixture. The brownish gas will get intensified on adding copper turnings. The confirmatory test of nitrate is ring test. For this test, we will take some salt in test tube. We'll prepare aqueous solution of it. Now we will add a saturated solution of freshly prepared ferrous sulfate to this. Now very slowly with the help of a dropper along with the wall of test tube, we will add concentrated H2SO4 to this. Move on to third category or group 3 of acetic radicals. The radicals belongs to this group are sulfate and phosphate. These radicals do not give any test with either dilute HCl or H2SO4 or concentrated sulfuric acid. These radicals have a specific test. So we will test sulfate of this group, and for this we need a salt containing sulfate anion in it, as well as we need dilute hydrochloric acid and barium chloride solution. We start the test. For this we take some amount of salt in the test tube. We will add dilute hydrochloric acid or HCl to this. We will shake the test tube a bit so that the salt gets dissolved in the acid. Now we will add barium chloride to this. Barium ions from barium chloride react with sulfate ions and gives a white PPT of barium sulfate. This confirms the presence of sulfate ion in the salt. The confirmatory test of sulfate ion is done with concentrated acids. We will add concentrated nitric acid to this. Observe the change. What is happening? Nothing happened. The precipitate do not dissolve in concentrated acid. This confirms the presence of sulfate ion. The confirmatory test is this only. If the precipitate do not get dissolved in concentrated acids, that means the precipitate form is of barium sulfate only. The white precipitate is insoluble in all inorganic acids.